When a client approaches us for leak detection, typically it's to solve one of two problems. They have too many false alarms with their current system and they're looking to improve that, or they're looking to improve their detection sensitivity or accuracy beyond what it's currently at. The implementation roadmap for a leak detection system starts with defining the problem and understanding the pipeline that we're going to be installed on. We typically ask for some pipeline characteristics such as topography, meter type, the pipe characteristics like diameter and so on, and then a little bit about what the fluid is going through that pipeline. Based on what the meter parameters are or meter characteristics are, we can calculate the meter uncertainty of the pipeline system, and using that meter uncertainty we can determine what the minimum detectable leak size could be on that system, and that's what we target for on our ultimate sensitivity of the leak detection system. Another important consideration in defining what we're trying to achieve on this pipeline is understanding the client's requirements in terms of their tolerance for false alarms versus their desire for the ultimate accuracy of the system. They kind of operate in a bit of a teeter-totter, where more false alarms means that you will get ultimately better or a smaller minimum detectable leak size. Whereas if you have a lower tolerance for false alarms, then we will look for something slightly larger than meter accuracy, just so we can prevent those false alarms from ringing in. Once we understand the pipeline characteristics and the leak detection performance requirements for the client, the next step is working on the data integration part, where we connect to a SCADA historian, database historian through an API, VT SCADA, Aviva, Ignition, and then databases like Postgres, MySQL, and a variety of others. Pipewise has flexibility to connect to all these different methods or connect to a brand new method. It takes a lot of the work off of the client's plate in terms of upgrading data acquisition systems or creating new assets for us to connect to. It allows us to use what they already have, minimize the work on their end to prepare something for a leak detection program to plug into. We strive to be as flexible and as willing to make modifications so that we can connect to whatever they have and just get going on the leak detection part with no changes or minimal changes to the way they're currently collecting data. For example, one client we're working with right now, they use Allen Bradley PLCs and they wanted us to connect directly to those PLCs and pull data out. And so we're developing a custom module that can do that, and eliminate the middle historian and just connect directly to the PLCs and pull the meter information out of there. Once we have data coming into the Pipewise database, the next step is to pre-process that data. We're looking to eliminate outliers and reduce the amount of noise in the instrumentation, so that once we put that data through our algorithms, the output is representative of the input signal, but not generating false alarms solely because potentially the meter's noisy or there's lots of variability. Now that we have the input signals that we need to put through the algorithms to do the CPM work and do the leak detection on the pipeline, we start the calculations and we need to look at two different modes of operation. The first is steady state and making sure that all other things are the same, the 2 meters balance with each other. Sometimes we need to put a small correction factor or make a recommendation on meter proving, just to make sure that when the flow rate is steady, the inlet and outlet meters are as close to each other as possible. Once we have a full understanding and a full base balance of the system, we start to look at what transient events look like on that pipeline, so that we can understand what a normal startup looks like, what a normal flow rate change looks like, a normal picking event, and any other operational changes that the pipeline undergoes on a regular basis. We look to understand what a normal version of each of those looks like, and we enable our signature recognition within the code to identify and prevent those normal events from triggering a false alarm. By understanding what a normal startup looks like, that enables us to one, prevent those false alarms from a normal startup, but also identify any startups that deviate from that normal. So if for example, there was a leak immediately upon starting up the pipeline, the Pipewise code's ability to recognize and understand what a normal startup looks like, and therefore what a abnormal startup looks like, enables us to maintain that sensitivity to leaks during those transient events, while preventing false alarms from triggering during just a normal transient event. After tuning for steady state and identifying and recognizing normal transient events on the pipeline, we now have a leak detection system that is ready to go out and detect leaks and minimize the number of false alarms. This tuning process, or this understanding of the current operating conditions of the pipeline, is not just a, we do it at the deployment phase and then we never look at it again, we never continue to improve it. We're looking at every system on a weekly or monthly basis, identifying any new transient events or changes to the behavior of the transient events we've previously looked at, and we're continually updating the way we handle those transient events to make sure that the statistical models and the balance that we're using isn't accurate only today, but it stays accurate over time and as the operation of a pipeline changes. Once a leak detection system is live, Pipewise supports that system by generating the documentation that our clients need for internal and external reporting. We analyze every false alarm that the system generates, identify the root cause, and add that root cause and the remediation for it back into our development cycle so that our features get better, our signature recognition methods get better, and for all of our clients, their false alarm rates trend downwards over time. We also help generate leak test plans for our clients, which test the sensitivity and accuracy of the leak detection system. They give the operators confidence because they see in the real world how the leak detection system works and how quickly. And then it can also satisfy your regulatory requirements for testing your leak detection system every year or every 5 years.